Now, let us have a look at the next topic, diversity receiver in core channel interference and what are its types. Very first thing we have to understand what is diversity. Now, this diversity is a technique used to compensate for fading channel impairments. We know by the limitations of the conventional mobile systems that most of the systems are disturbed by a particular phenomenon called fading. It leads to the problems in the channels, and it has to be taken care of. For this purpose, diversity is used, and it is going to be implemented using two or more receiving antennas, just like what we have seen in cell splitting technology. Not exactly just like. Now here we use them receiving antennas. Now here diversity is usually employed to reduce depth and duration of the fades experienced by a receiver in a flat fading channel. It senses that depth means how much time it is taking, how much time or how much damage it is going to do for a particular channel, that is going to be reduced, and at the same time that time required for that particular fading channel to disturb the voice channel is reduced with the help of the diversity scheme. Now these techniques, these diversity techniques can be employed both at the base station as well as mobile receivers, that is mobile units. Now let us see what happens one by one. Now actually, as per the theoretical concepts, diversity requires no training overhead, as a transmitter does not require one. It does not require any training overhead. If we remember what is meant by overhead, we might have studied this overhead in CDMA topics. What is meant by overhead? Overhead is not required in the diversity techniques. Now it provides significant link improvement with little added cost. With little added cost, why it is saying is we are going to add some antennas at the receivers. That is the reason why it is saying little added cost. Means equipment cost is going to be increased a little bit, not that much. Now, and it is going to exploit the random nature of wave propagation by finding independent signal paths for communication. Now it is going to find independent paths, means these signal paths are not at all related to each other. There is no dependent of one path on the other one. When you are using two or more antennas at the receiver end, it will go for acquiring at the different paths. Similarly, it is a simple concept where it undergoes a deep fade and another independent path may have a strong signal. And as there is more than one path to select from more than one path to select from, both the instantaneous and average SNRs at the receiver may be improved, often as much as of 20 to 30 decibels, which is a higher value than our required 18 decibels as studied in the last classes. Now, here it is said that it can select from one path, which is an instantaneous, both instantaneous as well as it will be having average SNRs. These are the main points we have to remember while going into diversity receivers. Few more topics are that a scheme which is connected to diversity is a method which is used to develop information from several signals transmitted over independent fading paths. Means there may be fading paths, but once as the scheme is employed, the signal is going to be taken in different paths. Let it be fading paths itself. Because of that, the scheme is going to be helpful. Once again, it is going to exploit the nature of radio propagation by finding independent signal paths for communication. Now coming to the objective of the diversity schemes. Now it is mainly useful for combining multiple signals in such a way so as to reduce the effects of excessive deep fades. If there are some deep fades available, means depth is more, means the damage is going to be more with the help of with the so-called fading channels. This diversity is going to reduce because we are going to combine multiple signals here. This is about objective of diversity. Now coming to the types, there are two types basically. They are macroscopic diversity and microscopic diversity receivers. Now coming to these types, what is first of all macroscopic diversity? Now it is useful for preventing large scale fading issues, and it is mainly caused because of variation in the terrain profile and the nature of the surroundings. This large scale fading, if you remember, it is mainly caused because of the variation in terrain profile. Terrain means it might be any upside down or downside up, like a what you call a hill or a man-made or any terrain, a street terrain, and the nature of surroundings. What are the surroundings are there in a particular given area? This particular large-scale fading is going to be caused. Now, how this is going to be prevented? Now, here it is prevented by selecting an antenna by which is not shadowed when others are. This allows increasing the signal to noise ratio. Means we use a word called shadowing. Now this is going to be, this shadowing process is going to be unshadowed. That is in simply not shadowed by the help of selecting an antenna. In simple words, this macroscopic is useful for large scale fading, which is caused by the differences in the terrain and the nature of the surroundings. Now, what is the polarization diversity? We might have heard this word so many times in the examination papers also, polarization diversity. Now, it mainly depends upon the decor relationship of the two receive ports to achieve diversity gain. Now, these two receiver ports must remain cross-polarized. Now, this is a simple concept. It completely depends upon two receive ports to achieve diversity gain. Now, and these are cross-polarized. Next, coming to the topic, space diversity. Now, a method of transmission or reception are both in which the effects of fading are minimized by the simultaneous use of two or more physically separated antennas, ideally separated by 1/2 or more wavelengths. Now, it is called as a method of, it may be transmission or it may be reception or both, trans receiver also sometimes, which is it is going to affect the fading effects. It is going to affect the fading effects, and it is going to minimize the fading by physically separated antennas with two or more separated antennas, or with the help of the wavelengths that are created for it. Now, once again, there is a small confusion with respect to this diagram. Space diversity, once again, is divided into different parts. Now, in the space diversity, the very first one, selection diversity. You can look at that space diversity, that so-called definition just now I have said, the principle. This principle is clearly applicable here. Signals received from spatially separated antennas on the mobile would have essentially uncorrelated envelopes. Envelopes means it is just like the carriers of those are different for different paths. Now, once these antennas are separated, now it creates a separate, that is uncorrelated envelopes of 1/2 wavelength or more. Next one, in the space diversity, selection diversity. Here, as the name suggests, selection, it gives the selecting the best signal among all the signals received from different branches, means different paths at the receiving end. When we are having two or more receiving antennas at the receiver end, when we are having so many signals arriving at the receiver end and we have an option for selecting a best signal, that type of diversity is called as selection diversity. Now, how this is going to have some principles. Now, it offers an average improvement in the link margin without requiring additional transmitter power or sophisticated receiver circuitry. Means it does not require more equipment, this particular selection diversity, as it involves directly in the selection process. Next point, selection diversity is easy to implement because all that is needed is a side monitoring station and an antenna switch at the receiver. As I said already, it is a simple process. It requires a small monitoring system which can be used to easily select, and an antenna switch at the receiver, as simple like toggling a toggle switch, like we want the signal or not. At the same time, it is not an optimal diversity technique because it does not use all of the possible branches simultaneously. It means it uses only the selected ones, and hence it will select two or three lines, two or three paths, and it will discard the remaining paths, and hence it is not an optimal diversity technique. Now, in practice, how its SNR is measured as signal plus noise divided by noise. Now, in this, for this particular selection diversity, it is very difficult to measure the signal to noise ratio because the point itself gives that we are not going to use the all the branches, means all the paths simultaneously. We use only a few selected ones, and hence measuring the SNR is going to be a very difficult task in the selection diversity techniques. Next one of them are, we call them as scanning diversity, or another name is feedback or scanning diversity. Now, what is this feedback or scanning diversity meant by? Now, the principle behind it is it will scan all the signals in a fixed sequence. You can see its diagram here. It will scan all the signals in a fixed sequence until the one with SNR more than a predetermined threshold is identified. This method is, as per the principle, this method is going to be a very simple to implement, requiring only one receiver. The resulting fading statistics are somewhat inferior to those obtained by other methods. But when you compare this fading statistics are achieved by this one, because as said, it is a very simple one, but the fading statistics are somewhat inferior, means a less productive or less optimal when compared to the another methods, because we are going to have a simple receiver. Next one, maximal ratio combining. Now, in this maximal ratio combining, what is the principle? Here the principle is simple. It is used for combining all the signals in a co-phased and weighted manner, so as to have the highest achievable SNR at the receiver at all times. Means you can simply say co-phased. It is going to have its phase values in line. That is angular values in line, and its magnitude values also, so as to have highest achievable SNR at the receiver at all the times. It is simply, you can say it as a mixture of the signals in a particular ratio of its ingredients. The ingredients are phase and weights. Phase and weights. Now, another topic here, equal gain combining. How this principle, how this particular equal gain combining is going to work. It is a somewhat connected one with the previous one. Now here it is used for combining all the signals in a co-phased manner with unity weights. Here the word unity comes as an extra thing here. Unity weights for all signal levels so as to have the highest achievable SNR at the receiver at all the times. Here it is going to use a particular, this is small difference between these two. Here it also uses a weight manner, that is weighted manner. Here also it is going to use weights, but in this equal gain combining, it is going to use unity weights. Co-phased is okay, but with unity weights it is going to use. That is the only difference between the maximal ratio combining and equal gain combining. Next one, next procedure, frequency diversity. Here in this process, the principle is the same information signal is transmitted and received simultaneously on two or more independent fading carrier frequencies. Means the same signal is transmitted and received simultaneously, means at the same time, that two or more independent fading carrier frequencies. It is simplest of the all. Now, what is the main things behind this technique? Now, very first is that here the frequencies are separated by more than the coherence bandwidth of the channel will not experience the same fade. Because of this particular separation of the frequencies will not experience the same fades. Similarly, the next point is the probability of simultaneous fade will be the product of the individual fading probabilities. Means the probability of simultaneous fade means at the same time, if these fades are going to happen, if you say there is a probability of, there is chance of a simultaneous fade is going to happen, it is the product of individual fading probabilities. Means it is going to calculate for all the fading probabilities. It is simply a product. Now, next point, this is often employed in microwave links, which carry several microwave line of sight links, which carry several channels in FDM techniques, that is frequency division multiplex mode. It is mostly used in microwave line of sight links. Now, moving from frequency to time. Here, the signals representing the same information are sent over the same channel at different times. It is similar to that of sending through the time slots. The simple thing is that the same information is sent over the same channel at different times. We choose different times to send the same information over the same channels in this diversity measures. Now, what are the simple points behind this particular time diversity? Now, here time diversity repeatedly transmits the information at the time spacing that exceeds the coherence time of the channel. Means it is going to repeatedly transmit the information, repeatedly transmitting the information at a time spacing. It is going to have a time spacing that is going to exceed the coherence time of the channel. Similarly, multiple repetitions of the signal will be received with multiple fading conditions, thereby providing for diversity. Multiple repetitions means sometimes there are chances of sending the signal multiple times with multiple fading conditions, thereby providing for a diversity. It requires a diversity to be applied there. One more is a modern implementation of time diversity involves use of rake receiver for spread spectrum CDMA techniques, which you study in the fifth chapter of your subject CDMA. It is a part of spread spectrum where multipath channel provides redundancy in the transmitted message. Redundancy, it is going to produce the redundancy, this particular concept. Now